Thanks for watching my video today. Let's prove another integral representation of the Euler-Mascheroni constant. Okay, so then what we're going to prove is the integral from 0 to infinity 1 upon 1 minus t negative e to the negative t dt upon t is nothing but the Euler-Mascheroni constant. Okay, let's get started. So let me denote the integral to be I. So I is integral from 0 to infinity 1 upon 1 minus t minus e to the negative t dt upon t. Now this 1 over t now split term by term here. Okay, you get integral from 0 to infinity dt upon t 1 minus t minus, okay, this one integral from 0 to infinity e to the negative t upon t dt. Okay, now this is 1 over t 1 plus t. If you use the partial fraction, then you get this one 1 over t minus 1 over 1 plus t, that apply here. So I is integral from 0 to infinity 1 over t minus 1 over 1 plus t dt. Okay, minus integral from 0 to infinity e to the negative t upon t dt. So now this integral split term by term here. So I is integral from 0 to infinity dt upon t minus integral from 0 to infinity dt upon 1 plus t minus integral from 0 to infinity. Now the limit representation of e to the negative t is limit n tends to infinity 1 minus t by n to the n upon this whole term. Okay, this the circle part is the limit representation of e to the negative t. Okay, so upon t, this is this one dt. Okay, now let's take this limit out outside the integral. Okay, so limit n tends to infinity, right, this integral from 0 to n. So because this n tends to infinity here. Okay, dt upon t minus integral from 0 to n dt upon 1 plus t. I hope you're clear. This n is infinity, okay, or infinity, so replaced by n. Okay, minus integral from 0 to n 1 minus t by n to the n upon t dt. Okay, now combining these two, I think, right, so you get limit n tends to infinity integral from 0 to n, this will be 1, right, 1 minus t by n to the n upon t both are here, dt minus, so the integral of this will be log of 1 plus t from 0 to n. Okay, so now putting that t by n is equal to x implies that t is nx, implies that dt is n dx. Okay, where n is a constant. Okay, so when t tends to 0, so x will tends to 0, of course. When t tends to n, then x tends to 1. Okay, this one. Therefore our new integral will be limit n tends to infinity integral from 0 to 1 already, right, 1 minus x to the power n. Okay, t by n is x upon t is nothing but nx into n dx. Okay, dt is n dx, right, minus log of this will be 1 plus n minus log of 1 plus 0, then is log 1, so log 1 is 0, so then is this 0 part is just 0, so you get log 1 plus n. Now this n and n we can get cancelled now, right, so you get I is equal to limit n tends to infinity integral from 0 to 1 1 minus x to the n upon x dx minus log 1 plus n. Okay, now next page, this will be the continuation of, okay, of that part. Okay, now putting that 1 minus x is u, so dx is negative, dx is du, then is we can say dx is negative du, right, implies that 1 minus u is nothing but x. Okay, so when x tends to 0, then u tends to 1, right, when x tends to 0, u tends to 1, when x tends to 1, u tends to 0. Okay, so our new integral then is limit n tends to infinity of the integral from 1 to 0. When x tends to 0, then u tends to 1, right, 1 to 0, 1 minus x is nothing but u, right, u to the n upon x is nothing but 1 minus u, negative du minus log 1 plus n. Okay, let's skip this one. Now I is limit n tends to infinity integral from 0 to 1. Because of this negative, this will be interchanged, right, upper and lower limit, so 1 minus u to the n upon 1 minus u du minus log 1 plus n. Now this is nothing but 1 minus u to the n upon 1 minus u is nothing but this is just the GP, right? Geometric progression, right? Then is k tends to 0 to n minus 1 of uk, right? So applying this one, then you get limit n tends to infinity sum from k equal to 0 to n minus 1 because of because interchanging this summation and this integration. Okay, so integral from 0 to 1 uk du minus log 1 plus n. So limit n tends to infinity sum from k equal to 0 to n minus 1. Integration of uk is uk plus 1 by k plus 1 from 0 to 1 minus log 1 plus n. So you get limit n tends to infinity sum from k equal to 0 to n minus 1. So when n is 1, so 1 to the any power is just 1, right? So 1 over k plus 1. When n is 0, this is just 0 minus log 1 plus 1. Now this is when k tends to 0, right? K plus 1, that means this will start from 1, right? This will start from actually 1, 2, 3. It's like this 1 plus 1 by 2 plus and so on. When k tends to n minus 1, then you get 1 over n minus 1 plus 1. Then it's actually 1 over n, right? So in other words, we can write limit n tends to infinity sum from k equal to 1 to n 1 over k minus log 1 plus n. So this is the basic definition of the Euler-Mascheroni constant, then is small gamma, right? Therefore our original integral, this one is equal already. So integral from 0 to infinity 1 over 1 plus t minus e to the negative t dt upon t is the Euler-Mascheroni constant. Okay, so this is how I approach it. Okay.